Hey guys, this is Karthik and this will be the third video for the digit DP series. We will be solving a problem digit sum from SPOJ. Now, I strongly recommend you to watch the introduction to digit DP video from my channel before you watch this video. But if you have the basics with you, you're good to go even if you don't watch that video first. However, if you watch it, I'm sure you will gain something out of that video. So yeah, that is one recommendation from my side. Another recommendation from my side is that guys, I need to support. You need to like the videos, you need to share it with as many people as you can, and you have to definitely subscribe to the channel. Now, because this is something that enables me to keep providing you guys with free content. I do not wish to partner with organizations, and these organizations will later on take the same videos from me and will be charging high prices for those videos. I wish to make the content for free because overall my motive was to help the community, help the programming community with good quality, high quality content that is available for free. To enable that, guys, I need your support in sharing the channel to a wider audience. That's it. So I am also planning a graph series, but you guys have to help me out in sharing the channel with as many people as you want, as many people as you can, in fact. Okay, so yeah, that's it. Let's start with the video now. Digit sum. You should read the problem and then we'll discuss the solution. The problem says that there are two integers a comma b. I would call them L and R. I like L and R more. And the problem is asking you to find out what is the sum of digits of x for all x from L to R inclusive. Okay, this is the question that that is being asked at SPOJ. You need to find out the sum of digits of x, and x is any integer from L to R. In fact, you have to iterate. The brute force would be iterating from L to R, taking the sum of digits of the current number x, then going to the next number, and you keep taking sum of digits of each and every number from L to R, keep adding them together in a overall total sum, and this total will be your final answer. This is what you need to find out. So you can look at the example that they have given. Let's say 28, 31. Capital L equal to 28, capital R equal to 31. Your answer will be 2 plus 8 equal to 10, 2 plus 9 equal to 11, and 3 plus 0 equal to 3, 3 plus 1 equal to 4. Add these up. 21, 21 and 3, 24, and 28. Your overall answer becomes 28. And this is exactly what you need to output for any L and R. Now, of course, you can go for a brute force, iterate through all the numbers from L to R. That is, iteration is R minus L. For each number, you will be breaking that number into its component digits. That takes logarithm of R time to the base 10. And this is your overall time complexity if you do it in a brute force manner. Not bad, but if you think about how large R can be, in this particular problem, R can be up to 10 power 15. Oh, where are the... Yep. So, L and R can be anywhere from 0 to 10 power 15. This is, the bounds are very big, and this particular time complexity does not work for that. So, let's go to Sublime and discuss a more efficient digit DP solution now. So, I'm interested in finding the sum of digits from L to R. Okay. First of all, I'm going to solve this problem in a different way. Instead of finding the sum of digits for every number from L to R, I will find out the sum of digits for every number from 0 to R. And so answer for 0 to R. I'll find out the answer for this range. And I'll find out the answer for the range 0 to L minus 1. And I'll use these two answers to get the answer for L to R. If you have doubt with this, I recommend that you watch my introduction to digit DP video. Okay, I'll be using these two things to evaluate my overall answer. So okay, now I just need a way to find out the answer for 0 to R. How do I do that? So R is a number having n digits. R is any number having n number of digits. For example, here n can be 5, so R is a 5-digit number. And for example, let's say it's 78362. Now this is just for example's sake. Your number could be anything. R can have any number of digits and it could be any digits. But for example's sake, I'm taking R equal to the 78368. You could take any R, it's just for example. Now you would like to generate all 5-digit numbers and you want to take the sum of digits of those 5-digit numbers or n-digit numbers, and you want to find out what do they total up to, right? The sum of digits of all 5-digit numbers or n-digit numbers in fact, so that the numbers are definitely less than equal to R, right? That is your goal. Now one thing that you might be thinking, why am I only thinking about n-digit numbers, why not n-1-digit numbers? So basically any number having less than equal to n digits can be represented as a n-digit number. So I can represent 0 as a n-digit number by putting 4 leading zeros. Similarly, I can represent 1 as a n-digit number, 2 as a n-digit number, and so on. So any number less than equal to R is a n-digit number for sure. Now I'll try to solve this problem. Also guys, remember that this problem actually can be solved without digit DP, but we are here to learn digit DP, so we will solve it using digit dynamic programming only. Now look at the number that I'm trying to generate. It's going to have 5 digits, of course. I'll think about the leftmost digit, right? The leftmost digit could be a 0, a 1, a 2, a 3, and so on till 7, not 8. Up to 7 it could be anything because I'm trying to generate numbers less than equal to R. So let's say that I put X at this position, at the leftmost position, I put in an X. Now if I knew the count of numbers that start with an X and are less than equal to R and has basically exactly n digits, then I know that any number starting with an X will be contributing at least this X toward the total sum. Let's say this is the total sum that I'm trying to find out, total. Okay. This is the total that I'm trying to find out. I know that any number of this particular form, X followed by some n-1 digits, is going to contribute at least X to the total. If I knew how many numbers of this form exist, let's say Cx is the count of numbers that start with an X and are having n digits and all of them are less than equal to R. If I knew that exactly Cx number exists that start with an X, then I know that these numbers contribute to the total at least X into Cx. Right, because there are exactly Cx numbers that start with an X, and since there is an X as a digit, all these will contribute X to the total. So it's basically Cx times X being contributed to the total because of this number. And then you're left with n-1 more digits. They will also contribute something, right? For these Cx numbers, these digits will also contribute something. We have taken this particular contribution, but what about this? So let's think about that now. So before moving any further, let me define this. Let's define dp of n as sum of digits, SOD, sum of digits. So sum of digits of all n-digit numbers. Of all n-digit numbers that are less than equal to R. So sum of digits of all n-digit numbers that are less than equal to R. dp of n can represent sum of all n-digit numbers without regard to R. So let's have another tight variable. Tight basically ensures that your overall number, that the numbers that you generate, stay less than equal to R. If you have some doubts regarding the tight variable, I recommend you watch the introductory video, but I'll explain it in brief here also. This tight variable will basically ensure that the number that I'm recursively generating by filling in the digits never exceeds R. So whenever I'm putting a digit, I make sure that the current number stays less than equal to R no matter what I do. Tight equals to 1 means that there is a possibility that my number might exceed R if I do something stupid. That means if I put in a larger digit. And tight equal to 0 means that no matter what digit I put from now onwards to the right of this position to generate my number, I can never exceed R. This is simply what tight represents. Okay, now we have a definition for dp. We are interested in finding dp of n, 1. So let's take an example, r equal to 78362. And initially tight is obviously 1. I'm trying to think about generating sum of all n-digit numbers that are less than equal to this R. Now at the leftmost position, I can either put in a 0 or I can put in a 1. Similarly, I can put in a 2 and anything up to 7. Nothing greater than 7 for sure. Because if I put something greater than 7, then my number is already greater than r, which is obviously not something I want. Now, let's say type is 1. That means you need to think about the r here. So if you put in a 0, the contribution that you get to your total is 0 times C0. That is obviously 0. So the count of numbers that start with a 0, basically how many numbers are there that start with a 0 and are less than equal to r having n digits. All those numbers have a 0 at the starting position or the leftmost position, so they contribute 0 into C0. So that contribution is good. But what about the remaining 4 digits? So for the remaining 4 digits, you have r equal to 8362. And now you are not under any tight constraint, right? Because you have put a 0 at the leftmost position. And now there is not a possibility that you will ever exceed r. Since it was 78362 and you have a 0 at the leftmost position, you can never exceed r. Even if you put 99999 at the remaining 4 positions. So that place you're good. But now you would be interested in finding out what are the count, basically what is the sum of all, sum of digits of all 4 or n minus 1 digit numbers regardless of r, of course, because type is 0, so that means regardless of r. And if type equals 1, that means with regards to the corresponding digits of r. Now regardless of r, what is the sum of all n digit numbers? That's nothing but dp of n0 regardless of r, n minus 1 0. What is the sum of digits of all n minus 1 digit numbers, and this will be the contribution due to this term, and you're good with that. If you put in a 1, you will get a contribution equal to 1 times how many numbers start with 1 having n digits less than equal to r, 1 into c1, similarly 2 into c2, and so on. If you put in a 7 here, then it's a bit interesting case, because then your r will be 8362 and you still have to give regard to r, because if you have put a 7 at the leftmost position, there is still a possibility that the numbers you generate having 4 digits can exceed overall r. So you still need to pay regards to r, and the contribution by this term will be dp of n minus 1 comma 1. That means sum of digits of all n minus 1 digits, and give regards to the corresponding digits of r as well. That means type stays 1. And guys, with this you have a solution. I'll just write it out and then we'll move to the coding part. So dp of n comma 1 can be written as, you put a 0 at the leftmost position, you get a contribution of 0 times c0, plus, since you have put a 0 in here, what happens is that you will basically be having r equal to something, and then you put a 0 in here. You're interested in n minus 1 digit numbers regardless of r, since the leftmost position of r will definitely be something not equal to 0. So regardless of r, you will be interested in sum of all n minus 1 digit numbers, and don't give any regard to r, because now there is no chance that you will ever exceed r. You want the sum of digits of all these 4 numbers as well. Similarly, if you put in a 1, 2, so on. So let's say ub is basically the corresponding digit of r, the upper bound, the maximum digit that I can put at the leftmost position equal to ub. So if I think about it in that way, then I put in a digit x equal to from 0 to ub minus 1 at the leftmost position, and the contribution I get by putting the leftmost digit equal to x is x into the count of numbers that start with an x having n digits and are less than equal to r, plus dp of n minus 1. Don't give any regard to r now, because there is no way that you will ever exceed r in the future, right? This is the contribution you get by putting x at the leftmost position, and this is the contribution you will get for the remaining n minus 1 digits. The other case is that you put in ub at the leftmost position. In that case, you will get this contribution plus dp of n minus 1. You still need to think about the corresponding digit or digits of r, and this is your entire recurrence. In this thing, the only place you will ever have to think about is how do you calculate c of x, and that I'll discuss while coding it up. But this is your solution. So let's start coding up. I've already written some boilerplate code so that we don't waste much time. Overall, I'm taking input of L and R. If L is not 0, basically if L equals to 0, then we were finding out the answer for R and answer for L minus 1. So if L is anything, I will be like L minus 1, make L equal to L minus 1. But if L is 0, then let it be 0. I don't have to deal with that case. Okay, then I convert the L and R to strings. If you have some doubt, you can ask me in comments, but hopefully it is pretty straightforward. If you have doubts, you can use pen and paper and think about what this means, or you can ask me in comments. Now what we'll be doing is, we'll be writing some code. Okay, so let's have a function solve that takes in a number R, and I'm interested in finding sum of digits of all n digit numbers given the type variable type. If type equals 1, that means with regards to the corresponding digits of R. If type equal to 0, then regardless of what R is. So initially I'm interested in finding out two things. So let's say integer, okay, ll SOD till R equals to sum of digits till R equals to pass in R, pass in the number of digits in R, that is R dot length, and initially I'm worried I need to give regards to R. Similarly, SOD of L, what is the sum of digits till L minus 1, you pass in L, you pass in the number of digits in L, that is L dot length, and you have to pay regards to what L is, because you want to generate numbers less than equal to that. Now you'll be like, okay, see, your final answer obviously becomes SOD R minus SOD L, and you're done, solved the problem. Let's just write this solve function now. So for writing this, let's think about it. If the number of digits is 0, then of course, if there is no digit in the number, there is no sum of digits, right? It's basically going to be 0 only. A number having 0 digits, the sum of the digits for that number is 0. Okay, that's okay. Now otherwise what happens? Otherwise I try putting a digit at the leftmost position. The largest digit I can put at the leftmost position depends upon the corresponding digit of R. So the largest digit I can put at the leftmost position is UB. Now if type is 0, then the largest position I can the largest digit I can put at the leftmost position is obviously 9, because since I'm not paying any regard to R, I can generate any number having n digits, and that number could be 99999, right? So if type is 0, then of course you can put in any digit at the leftmost position, so 9 can be the case. But what if type is equal to 1? So if type is equal to 1, in that case I have to pay regards to R. I need to make sure that I don't put a digit such that I exceed R. I need to make sure that the number I am generating stays less than equal to R. So what is the corresponding digit at R? The corresponding digit at R is R dot length minus n. Now how is this the corresponding digit of R? For that you can watch the first video, although it's pretty straightforward why this is the case. Because if n equals to R dot length, then you are talking about R of 0 as the corresponding digit. If n equal to let's say if R dot length equal to 5 and n equal to 4, you are thinking about 4 digits, then you'll be the corresponding 4 digits of R, and the leftmost digit would be 5 minus 4, that means R at 1, right? And you subtract 0 from it. Yep. If type equals to 1, this is the largest digit you could ever place at the leftmost position. Now you'll try putting all these positions, and meanwhile see what is the overall contribution you are getting to the total. So let me initialize the total to 0. Now let's try putting every digit at the leftmost position from 0 till UB. Let me check if I'm logged into SPOJ. Yep, I am. Yeah. So if I put a particular digit at this position, as we discussed, to the total we get a contribution of total plus equal to dig into how many numbers start with this particular digit, right? C of dig. And we also talked about having exactly n minus 1 digits. So let me also pass in that how many numbers are there that start with this particular digit dig and have n minus 1 digits. What about type? You need to think about R also, right? Because let me just discuss that quickly. Let me go to Sublime. So let's say R equal to 3862. So how many 4-digit numbers exist if you don't give any regards to r? That means you are not at all worried about r. You can generate any 4-digit number, that could be 0, 1, 2, 3, so on till 99999. So basically you can place any any digit at the leftmost position, any digit here, any digit here, any digit here. So it's basically 10 power n or 10 power 4. The count of numbers that exist having exactly n digits if you don't give any regard to r. What about the count of digits that exist if you do pay regard to r? Then you can put in a 0 here. If I put in a 0 here, then I'll be interested in how many 3-digit numbers exist, and you don't need to think about the corresponding digits of r anymore, because you put in a 0, now the remaining 3 digits could be anything. So that's basically 10 power n minus 1 contribution for that. If I put in a 1, similarly another 10 power n minus 1 digits, because for the remaining 3 digits you can put in anything. Similarly, if I put in a 2, another 10 power n minus 1 digits for that. But if you put in a 3 at the leftmost position, then again you will be like, okay, how many 3-digit numbers exist? How many 3-digit numbers exist with regards to 832? You have to make sure that you don't generate any number greater than 832. So you will just continue doing this. You will be like, okay, what if I put in a 0 at the leftmost position, 1, 2, so on till 8. And we'll just code this thing up quickly. Although this can also be solved using digit DP, but it's pretty efficient like even in the brute force manner, because you are, as soon as you don't have to pay any regard to r, you are using 10 power n as the number of count of numbers having exactly n digits if you don't pay any regard to r. Okay, let's code this part also. So this thing here, yep, I'm interested in how many what is the count of numbers, CNT, count of numbers having exactly n minus 1 digits, and do I need to pay regard to r or not? That will be specified by the variable tight and pass in r. Okay, do I need to pay regard to r or not will be specified by tight. Now if tight is 0, then in that case you will never have to pay regard to r. The only case in which you have to pay regard to r is that tight is already 1 and the digit that you place at the current position is equals to ub. So if tight is 1 and digit equals to ub, in that case you have to pay regard to r. Okay, otherwise you're good. This is the contribution made by this particular digit if you put it at this position. And the other thing would be, you put this digit and you think about what is the contribution or the sum of digits of the remaining n minus 1 digit numbers. That is solve, pass in r, sum of digits of n minus 1 numbers, and what happens to tight. So you need to the same thing, right? The only case in which you have to pay regard to r is that if tight was already 1 and the digit you place at this particular position is equal to the upper bound or the corresponding digit of r. That's it. You can return total now. All we have to do is implement that CNT function as well. So let's say LLCNT, pass in the string n and tight. Let's talk about the base cases here. So as discussed, what if tight is 0? That means you don't have to pay any regard to r, you just want to find out the count of n digit numbers. In that case, it's simply 10 power n. So return power 10, n. Now using this power function is never a good idea because it generates a decimal result. Okay, so what I'll do is I'll add 0.1 to it. So even if it's like a bit here or there, instead of having 1000 instead of generating a result of 1000, let's say it generates 999.99999, it becomes 10,000. Or even if it generates 1000.00001, then also it stays 1000 in integer. This 1.0.1 helps in that. Now if tight is 0, you can simply return it. If the number of digits n equals to 0, then what? You can return a 1. Why is that so? Because if tight is still 1 and n equals to 0, this means you generated a number that was exactly equal to r, and that is one number, right? You have to keep in account for that. So you return in a 1 here, or you can say the empty number is 0-digit number. you have a contribution of 1 for that. Okay, so that's it. You have two base cases now. Now if tide was not equal to 0, that means tide is equal to 1. You need to pay regard to r. So let's say count of numbers, ll numbers equal to 0. You try putting in every digit at this particular position. Let's say integer ub equal to, ub's thing remains the same. The largest digit I can put it at this particular position equals to this. Tide is definitely equal to 1, so I don't need the conditional. Now I'll try putting in 0 and up till ub. And I'll be like, okay, numbers plus equal to, what are the count of numbers having n-1 digits, and tide again varies the same way. Do I need to give regard to r or not? Depends upon what digit I place at this particular position. And finally we can return the count of numbers. We're done. Let's try running the code. String was not, oops. So we have 3 test cases available, 3, 0 and 10. Okay, 28, 31, 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess this is the correct output. Nice, I'm happy. Now I've still not applied the dynamic programming in this. So I think according to the constraints, R can have at most 15 digits. So let's say 18 for that. And tide is obviously either 0 or 1. So now I have a DP table that I'm going to use. I'll initialize the table to -1, meaning that I have not solved a particular sub problem yet. And I'll have to call this memset every time before I call the solve function. Now in this case, have you solved the sub problem before? That means if dp of n comma tide is not -1, that means you've already solved the sub problem before. So don't solve it again, just return the answer. And if you haven't solved the sub problem before, solve it, store it and return it. Good. Let's see if we still get the correct answer or not. Yep. Let's try submitting the code on SPOJ now. Hopefully this should work. And guys, if you like the video, make sure to subscribe to the channel. And as I said initially, guys, do share the videos because that will definitely enable me to make more and more content. Also, let me know if you think the content that I do put out is high quality and it is helping you out. That does make me happy. And of course, getting an accepted also makes me very happy. So share the video, guys, like the video, and bye bye. See you in the next video.